Welcome to Math with Mrs. Bibb. Today we will be discussing quadratic functions. There are three forms of quadratic functions that we will discuss in this lesson: standard form, vertex form, and intercept form. I've already written some information on this slide about things that you should know. So if you'll please pause the video, fill in everything that I have written there, and I'll talk for a little while. So if you want to let it play while I talk for a little while, and then pause when I stop talking and I'm ready to go on to the next slide. To find the vertex in standard form, you want to start with the axis of symmetry, and I did not write that down, so I'm going to put a little star there. You want to start with the axis of symmetry. You want to find x equals negative b over 2a. And I want to make sure to point out that a, b, and c come from your standard form, ax squared plus bx plus c. That's where they come from, ax squared plus bx plus c. That's where your b and your a come from. So it's the opposite of b over 2 times a. So if b is positive, then it's negative b. If b is negative, then it's positive b over 2 times a. My y-intercept is my c value. Because the y-intercept is where x is 0, if you substitute 0 in for x, then you definitely would get this c value. So the y-intercept is c. The domain for these types is always negative infinity to positive infinity. And the range is based on the direction that the graph opens. If a is positive, a greater than 0 means a is positive, then my domain will always be bracket y, which is the y-coordinate of your vertex, to positive infinity. If a is less than 0, or if a is negative, then it's going to be from negative infinity to the y-coordinate of the vertex, which comes from up here. So speaking about that for just a moment, when a is positive, that means you do not have a reflection across the x-axis. When a is negative, you do have a reflection across the x-axis. So think about those transformations. And then a maximum value. If your graph is pointing down, if a is less than 0, that means a is negative, so your graph is pointing down, then your maximum value is the y-coordinate of the vertex. The maximum point, the relative maximum, or actually the maximum, is that ordered pair, but the maximum value is the y value of the vertex. The minimum value, so if a is positive and it points up, then the minimum value is the y value of your vertex. So that's your minimum point, and the actual minimum value is the y value of your vertex. Make sure to include over here, and this goes for all the graphs, to graph you reflect the y-intercept across the axis of symmetry, and you also plot your vertex. And I'll do some graphing, I'm sure, on some of these examples. So I'm going to be moving on to the next slide now. Vertex form of a quadratic equation, which is my all-time favorite form because it's so easy to get to the answers. Vertex form is HK, and I want you to remember that this is your left or right movement. Left or right is your x coordinate, and your up or down movement is your y coordinate. The A tells you your direction and your size. So direction or size for the A, left or right, up or down. So HK is my vertex. The axis of symmetry is x equals. I want to point out, I did not point it out on the last slide. The axis of symmetry is a line. It's a vertical line. So you have to have x equals whatever your h value is, whatever x is in the vertex. The y-intercept is not as easy in this form because it's just not. So to find it, you're going to substitute 0 in for x. So you'd put 0 here. And then you'd simplify. You'd use order of operations to find the y value when x is 0. So I would do what's in the parentheses first, I would square that, I would multiply by the a value, and then I would add whatever k is to find the y-intercept. Domain, again, is negative infinity to positive infinity. Range is still the same. If a is greater than 0, if a is positive, it's going to point up, which means it starts here at the bottom and goes to positive infinity. It starts at the y-coordinate of the vertex, so that's why I highlighted those the same. I guess you could put k there if you wanted, but it's the y-coordinate of the vertex. That's why I have y, not the y-intercept. If a is less than 0, that means it points down. So for the range, it's coming from negative infinity to the y-coordinate of the vertex. So this if it's pointing down, this is if it's pointing up. It has a maximum value if it's pointing down, and that maximum value is the y-coordinate of the vertex. So that would be k here. And it has a minimum value if it's pointing up, and that minimum value when it's pointing up is the y-coordinate of the vertex. So again, those go together. And to graph this, you're going to graph the vertex, the axis of symmetry, the y-intercept, and reflect the y-intercept across the axis of symmetry. Moving on to the next one. The next one is called intercept form, and it's called intercept form because the way this is listed, and I don't think I wrote that, so I need to write that, but I think my pen is charging right now. Let's see if it's gotten a little bit of a charge on it. The way it is written, you know the x intercepts automatically, so I'm going to include that here. Now my pen is not working at all. I'll just have to write with my finger. So the x-intercepts. The x-intercepts are P and Q. And just like it's being on the inside, it's the opposite. So if this were x minus 4, P would be 4. If this was x plus 2, then Q would be negative 2. So P and Q are my x-intercepts. Please do include that in your notes. All right, so let's go through everything I have written down. So hopefully you've been writing as I have been talking. Hopefully you're listening to me or you're reading the closed captioning. The vertex. Before you find the vertex, find your axis of symmetry just like we did on standard form. X equals P plus Q divided by 2. So you have to know your P value and your Q value when you are finding the axis of symmetry. You have to know your P and your Q. So X equals P plus Q divided by 2. The y-intercept is 0 y-intercept, and you substitute 0 in for X to find the y-intercept. So you'd put 0 here and 0 here, and you would do what's in your parentheses first and do what's in these parentheses. Then you'd multiply A times this value, and that would be your y value for your y-intercept. Domain, still negative infinity to positive infinity. The range, this all still looks the same. Hopefully you notice that all of this looks the same for each of those forms. Back to the vertex, X equals P plus Q divided by 2. That's your X. To find your Y, you substitute X into the original equation and simplify to find Y. I'm sorry I left you so little space to draw these graphs. They don't have to be huge, and I'm hoping for my pen to start working. I did go check. It is charged to 100%, but it is not working for some reason, and I don't know how to make it start working. So if you will sketch these two graphs, and then we're going to write down a couple things, and I might just have to write with my finger, although it wasn't working very well, but that's okay. Okay, so the first thing I'm going to do is I'm going to write what that dotted red line is. So find yourself some space and write that this is the axis of symmetry. And I draw it dotted. I'm so sorry, I'm writing with my finger. So I draw it dotted because it's not really there and I don't want to confuse it with the y-axis. So I draw a dotted vertical line for the axis of symmetry. x equals h, or x equals whatever the x value is of the vertex. The axis of symmetry goes through the center, so it goes through the vertex. The axis of symmetry goes through the vertex. And that's one thing we want to write down, is the vertex. So let me pick a different color. This point, and I'll go around this way. This point, they are called the vertex. You draw this in whatever way you feel is best. And then I want to circle with white this, oopsie, this, and this. I need to get my notebook and look. I think I wanted to write down, obviously I think all of you know that those are x-intercepts. That's what those are x-intercepts. So I'm going to write that. And then what are all the names for x-intercepts? The more we hear this and the more we talk about it, the more we write it down, we will get it into our brain. And I have it written down on my notebook paper. Yes. So those are all called, and this goes together. Those are all called x-intercepts. Hopefully you know they're also called solutions. If you're asked to solve, you're finding the solutions. And the solutions are the x-intercepts. If you're asked to find the roots, you're finding the x-intercepts. If you're asked to find the zeros, that is the x-intercepts. So please make sure that you have that written down, that those are all the same thing, x-intercept, solutions, roots, and zeros. And if writing in a color that's the same helps you, then please feel free to do that. Moving on to the next slide. We're going to graph f of x equals x squared plus 2x minus 3 without Desmos, and we're going to state the domain and the range. Right now I could state my domain because the domain is the same, and again I'm writing with my finger, I'm so sorry. My domain is from negative infinity to positive infinity. And I'll name my range right here. And I'll draw the graph below that. Okay. First I'm going to find, I need the vertex, but I can't find the vertex until I know the axis of symmetry. Sorry, I keep moving that axis of symmetry. So it's not very fun with your finger. Okay. So x equals, I'm going to name A, B, and C. A equals 1, 1x squared. Keep moving all this stuff down. Okay. A equals 1. B equals 2. C equals negative 3. So x equals negative b over 2 times a. Simplify that. X equals... My phone was ringing and they hung up before I got there, so that's okay. All right, so I'm going to simplify. I'm going to multiply in the denominator first. Negative 2. 2 times 1 is 2. And then negative 2 divided by 2 is negative 1. So my axis of symmetry is x equals negative 1. X equals negative 1. So I'm going to go to negative 1, draw a dotted vertical line. And then I'm going to go up here to the top, and I'm going to put negative 1 in for x. And then I'm going to substitute to find this y value. So y is going to equal negative 1 squared. I'm substituting into this original equation, negative 1 squared plus 2 times negative 1 minus 3. I don't know if I'll be able to write that so small. Please, pen work. I finally got it to work. Okay, so x equals negative 1. And I can make that smaller. Negative 1 squared plus 2 times negative 1 minus 3. So y is going to equal negative 1 times negative 1 is positive 1. 2 times negative 1 is negative 2 minus 3. And then 1 minus 2 is negative 1. Negative 1 minus 3 is negative 4. So negative 1, negative 4 is my vertex. So I'm going to go left 1, down 1, 2, 3, 4. Negative 1, negative 4. My y-intercept is C. So my y-intercept is negative 3. So that means that my graph crosses at negative 3. I'm going to reflect this point, negative 3, across the axis. It is 1 unit away to the right. So I'm going to go 1 unit away to the left and put a dot. And then I'm going to draw to the best of my ability the parabola that is f of x equals x squared plus 2x minus 3. I also want to include maximum or minimum value here because I just think it's important to talk about it since I listed it before. Does this graph have a maximum or a minimum? Well, first of all, I know this graph is pointing up because A is positive. So since it's pointing up, it has a minimum value. The minimum point is negative 1, negative 4. But the minimum value is negative 4, the y-coordinate of the vertex. Example 2. It wants us to compare the graph of f of x to a quadratic function g of x with a y-intercept of negative 1. Okay. So from the graph, f of x appears to have what kind of maximum? Because they both have a maximum. Well, this ordered pair is 1, 2, 3, 1, 2, 3, 4, 5, 3, 5. So maximum value of 5 for f of x and positive 1 up 2. So 1, 2. Maximum value of 2 for g of x. So f of x has a greater maximum value. Sorry, my paper's about to hit the floor. Maximum value. Okay, moving on to the next one. A ski resort has extended hours on one holiday weekend per year. Last year, the resort sold 680 ski passes at $120 per holiday weekend pass. This year, the resort is considering a price increase. They estimate that for each $5 increase, they will sell 20 fewer holiday weekend passes. So the first thing we're going to do is define our variables. What does x equal? What does y equal? X is the number of $5 price increases. Y is the total amount of money made. Okay. So Y is going to equal the price of each pass times the total number of passes sold. So let's look at that. The price of each pass. With the number of $5 increases. So each pass, 120 of them, plus $5 for the increase. The price of each pass, I should say. And then the total number of passes is going to be 680, because that was how many ski passes the resort sold. 680 minus the 20 fewer weekend passes that were sold. So minus 20 times X. So my equation, Y is going to equal 120 plus 5X times 680 minus 20X. And we are going to multiply. There are places that call this FOIL. I don't call it FOIL. I call it distributing. We are going to multiply. Let me show you what I mean by distributing. You're going to multiply 120 by both of these. And then you're going to multiply 5X with both of these. And then you'll add together those products. So 120 times 680 is 81,600. And then 120 times negative 20X is negative 2,400X. Now I'll do the green. 5X times 680 is 3,400X. And 5X times negative 20X is negative 100X squared. And then I'll combine my like terms. Y equals 81,600 plus 1,000X minus 100X squared. And I really should put that in descending order. Y equals negative 100X squared plus 1,000X plus 81,600. That is my equation. And I want to find how much they should charge in order to maximize the profit. So I want to find the axis of symmetry first, which will give me my X. And that's the number of $5 price increases. So I'm going to, let's see, I got a little bit of space to the left. I'll go to the left first. So I'll draw an arrow over here. So my axis of symmetry is X equals negative B. Let me grab a red pen and I'll name A, B, and C. A is negative 100, B is 1,000, and C is 81,600. So negative B would be negative 1,000 divided by, it could be over 2 times A, over 2 times negative 100. So X would equal negative 1,000, simplify the denominator, divided by negative 200 That's positive 5. So 5 is the number of $5 price increases. And then we're going to take that number 5 and substitute it in for X, for the price of each pass. So 120 plus 5 times 5 is 120 plus 25, so $145. How much should they charge in order to maximize the profit? So that's how much they should charge is $145. I'm going to write the answer here to the right. They should charge $145 for each weekend pass. Okay, that answers letter A. Letter B says, find the domain and the range in the context of the situation. Okay, my domain is going to be from 0 to 34. Now, how I get 0 to 34, I'm going to put domain from 0 to 34. How you get that is I can't have a negative number. Let's start here. I can't have a negative number here. The total number of passes cannot be negative. So if I put 0 here, I can't have negative number of passes, period. The number of $5 price increases has to start at 0. So you either have 0 or you have more. And then the 34 comes from looking at 120 plus 5x times 680 minus 20x. No value is going to make this become a negative number, or 0, except 0. But what value would make this become 0? And that would be if you put 34 in. 680 minus 20 times 34 is 680, and that would become 0. If you go any lower than that, or any higher than that, then this is going to become a negative number. So that's where the 34 came from. If you set this equal to 0, because that's the max, this can be, is 0, not max, minimum, sorry, then this 680 minus 20x equals 0 would give you that highest number that you could have, that 34. So to describe that in the context of the situation, let me grab a pen. The number of $5 increases can range from 0 to 34. And then for the range, oh, I hate to use the word range there, can vary. Let me go back and change that. Can vary from 0 to 34. And then for the range, my range also cannot be negative. And the maximum amount of money that can be generated, if I substitute 5 in for X, let me do that over here. So if I substitute 5 in for X, Y equals negative 100 times 5 squared plus 1,000 times 5 plus 81,600. So y is going to equal, this is 25, negative 2,500 plus 5,000 plus 81,600, and all of that should be 84,100. So that's your maximum value, is 84,100. So my range would be from 0 to 84,100. And in explaining that in the context of the situation, the maximum amount of money of, let me erase that. The maximum amount of money earned can vary from $0 to $84,100. And that's my answer for that one. Moving on to the next one. Rate of change for nonlinear functions. The average rate of change is found by doing f of b minus f of a divided by b minus a on an interval that will be given to you, a to b. It'll tell you your interval. So you're substituting into the function to find this value, you're substituting to find this value, and then you're just subtracting those two numbers that are given to you. So we're going to determine the average rate of change of f of x equals negative x squared plus 2x minus 1 over the interval negative 4 to 4. So what we're going to do f of b minus f of a over b minus a. So I am going to substitute positive 4 in for x. Then I'm going to substitute negative 4 in for x. And then I'm going to substitute positive 4 in for b and negative 4 in for a. So let's do that. F of b would be the opposite of 4 squared plus 2 times 4 minus 1 minus, and I'm going to put a bracket here so I can remember to distribute this negative sign to everything. So minus negative 4 squared plus 2 times negative 4 minus 1, all divided by b minus a. So my denominator is actually going to become 8. Okay, so I'm going to simplify. Negative on the outside, and then that's, I'm going to put negative 1 times 16 plus 2 times 4 is 8 minus 1 minus, I'm going to keep my bracket for now, negative 1 times negative 4 squared is positive 16. 2 times negative 4 is negative 8 minus 1. I'm going to keep that 8 in the denominator. I'm going to multiply. Negative 1 times 16 is negative 16 plus 8 minus 1. And then I'm going to have minus negative 16 minus 8 minus 1. Then I'm going to combine what's in the brackets. So negative 16 plus 8 minus 1. I'm going to put a subtraction sign. Negative 16 minus 8 is negative 24. Negative 24 minus 1 is negative 25. All divided by 8. And this is going to become plus positive 25. So let's do the math all the way across. Negative 16 plus 8 is negative 8. Negative 8 minus 1 is negative 9. Negative 9 plus 25, I believe, is 16. So I'm going to get 16 in the numerator, 8 in the denominator. 16 divided by 8 is 2. The average rate of change for that example is positive 2. I hope I left you enough room to do those. If not, you are welcome to do that on a separate sheet of paper. Now for the last one, it's actually a little bit easier because all you have to do is use your table. Your values are already given to you. You just have to use your table. F of B minus F of A divided by B minus A. And remember, this says find the value of y given this x value. Find the value of y given this x value. So let's substitute our b and our a in. This is a, this is b. So b is 3, a is negative 3. Okay, so let's go do that. F of 3 minus f of negative 3 divided by 3 minus negative 3, which ends up being plus 3. So 6 goes in the denominator. Now, to use your table, let me explain again. Find y when x equals 3. Find y when x equals 3. So when x equals 3, y equals negative 24. Okay, explain this one. Find y when x equals negative 3. Find y, so find this value, when x equals negative 3. Well, when x is negative 3, y is 48. So minus 48. Next, I'll do the numerator. Negative 24 minus 48 is 12, 72, negative 72. Please tell me if I'm wrong. I'm pretty sure that's right. And then negative 72 divided by 6, I'm pretty sure that is negative 18. So the average rate of change for example 5 is negative 18. I hope you have a wonderful day.